Hello everyone. Today we look at this board that I think has the least ICs and components in my collection. This is a board that comes from the scrapyard and I already fixed some of the battery damage, so we are not going to go into a repair attempt today, although I don't know if this board works. This we'll figure out in a moment. But you can see how there were some traces damaged. I tried to fix it as good as I could. I think there is still a lot of corroded solder everywhere on these resistors and capacitors. I cleaned the socket for the keyboard controller, which is under the sticker with the number 6042. We have the real-time clock, the WinBond, and we have a BIOS for a 386SX apparently. But there is a Texas Instruments TX486SLC CPU on this board. So this is a faster CPU that you can get for a 386 platform. I know there are clock doubled chips available as well, but this is just the 33 MHz version, which isn't too bad because this is a 5-volt part. I think for clock doubled parts, you have to be careful because some of them have only a 3.3 volt core. This one, I think, is a 5-volt core. Now, what I've seen on another YouTube channel, actually it's K2s Retro Workshop, he already had this board on his channel and he couldn't get the 1 kilobyte cache to work that is on the CPU. And this might be due to some missing connections on the CPU. As you can see here, there are no traces. According to him, there are no traces that are under that CPU. And we'll have a look at it and we'll try to figure out which pins these are and if there are pins that are related to the cache management on the CPU. And that would be a shame because this board has a CPU with cache on it and it can't use it. And you can see there are no other cache chips. So what I want to figure out today is if this cache works on the CPU, and if it doesn't, can we maybe use the CPU and transplant it to one of the boards that I recently fixed. You may have seen the restoration of this board. This board only has a regular 386SX from AMD. And as you can see, here is also pin 1, but here there are more traces leaving from the CPU to the chipset than on the other CPU. So maybe this is related to cache, because we have seen in the BIOS of this board that there is a cache option to enable the internal cache. Maybe it makes sense to swap these two CPUs, but we will figure that out. First, we need to see if this board works, and this is what we will do right now. So this CPU is also an SX CPU, which means we only need 2 of these memory modules. And you can see these are actually really nice memory sockets. They are gold plated here. How do these ones go in here? No. Ah, this one, like this. Okay, this is, I think, the other way around. This is not what I'm usually used to, that the memory chips face the other way, I think. Okay, so here we go. Now we have 8 megabytes of memory on this board. We have the 486SLCE chip, which is a 5-volt part. And yeah, let's see if this board works. And as always with untested electronics, I will put on some goggles just to make sure nothing is going to fly around. But here we go. Let's test this board for the first time and see what happens. Okay. Hey, we get postcodes. I forgot the... I'm happy the board works. I forgot the speaker. Okay. So let's try this one more time. And let's see if we post. There is nothing coming from the speaker. I tried so many things. I moved the VGA card to different ISO slots, checked and verified the jumpers, reseated the keyboard controller chip, but this didn't make any difference. So I went ahead and removed the sockets and ICs. There was still a lot of dirt and corroded solder. I took that opportunity to install sockets for the real-time clock and the BIOS chips. And of course, I also tested the two logic ICs below the keyboard controller. All of this didn't make a difference. The logic ICs work and the board still refused to post. Then I tried different memory modules. 2 modules, 4 modules, different speeds, but the only thing I could manage to get from this board were 3 short beeps. The 3 beeps mean that there is an issue with the first 64 kilobyte block of memory. So it looks like we have a memory issue. But before we continue, a quick shout out to PCBWay, the sponsor of today's video. This Christmas, take your electronic projects to the next level with PCBWay's incredible holiday deals. Get up to 50% off PCB and assembly orders, or get free prototypes for Christmas-themed designs, and get access to many festive coupons. Don't forget all the other services PCBWay has to offer: CNC machining, 3D printing, sheet metal fabrication, injection molding, and of course anything related to PCB manufacturing and assembly. You can also try your luck by unboxing blind boxes, or challenge yourself by answering 2 questions about electronic circuits. So, head over to PCBWay.com for all your PCB needs this holiday season. Links are in the video description. I'm sorry for my voice in the next section, but I just woke up and had an idea to test all the connections from the memory sockets to the chipset, because I had done some work on this chipset before. So I tried so many things now, and I think I found the issue. As you can see, I went pin by pin on the memory sockets, and this is really the only thing you can do. You have to check the connectivity between these pins and either the chipset or the CPU. There is no guarantee that you will find something, but in my case I think I found it. And really it's just checking connectivity. Some of those pins go through this resistor arrays, and then you have a little bit of resistance there, and you have to figure out if your multimeter will beep. So you have to figure out how your equipment works. But let's see this line, which is I think it's a data line. No, it's an address line. This is pin 11. So address lines are supposed to be identical through all of these pins in a row. So they all connect to all 4 sockets. And if I follow along, I think this will go here to pin number 4. Yes, with 0 ohms, and it will continue through this resistor array and arrives here with a 10 ohm resistance. And from here we have to find where this pin goes, and it goes to our chipset here. Now if I probe the pads, this is our pad. But if I go to the pin, there is no connectivity to this pin. Even though it is connected, you see, I can't move this. There is somehow no connectivity to the chipset. There you go. Now I broke it loose. But I think I have to double check this connection here. I reflowed this entire section because it was corroded. But yeah, there's no guarantee that you have a connectivity there. So I will reflow this chip now, and then let's see if the board posts. Okay, I think I fixed the problem. Let's see if this board now posts and does no longer get stuck on some weird memory error. So yeah, let's see. I'm really curious now if this board will post. Yes, it works. Nice. Now I can finally run some benchmarks on this board. And we can see if this board has the cache of the CPU properly implemented. So let's install the 500 megabyte drive quickly. And 63 sectors should give 498 megabytes. Now we can continue with the floppy drive A, which is a 1.44 megabyte drive. Let me just set quickly the date and time as well. Now let's see what we get in advanced CMOS setup. This is the important part. Oh, okay. So there are not many options here. Let's see if we have something related to cache. We have no numeric coprocessor, floppy drive, boot up sequence. I want to boot from drive C. And we have only two options to shadow locations, memory location, C000 and F00. So these two, maybe these ones will only show up when they are detected. I am not sure. And here we have the Cyrix cache. So this is interesting that it's in the BIOS. Let's see if we can use it. Yes, let's enable it. And otherwise, we have an auto detect for hard drive, so I could have used that. But that's okay, we don't need this. Okay, let's boot into DOS. (16 megabytes). Floppy drive seek. And we're booting. Yes, we're there. Wow, okay. So this one issue on the chipset, this one pin that looked like it was attached, but it wasn't, was the problem. So I made sure to reflow this entire side one more time. I did this before. There was some bad corrosion on it. But yeah, it fixed it. So, and the CPU is getting quite hot. So what I will do now, before I do anything else, I will just get a small heatsink and put it on top of the CPU. Okay, we have a Cyrix 486 SLC. And it says size of level 1 cache is 1 kilobyte. So that looks good. Let's try SpeedSys, because this is the one where we see a graphical representation of the cache. And here I can already say that with a score of 16.8, that CPU is definitely a lot faster than a 386SX. I almost see that we are reaching a DX250 performance level here. But yeah, this is looking great. And let's see what happens in our cache benchmarks now. Okay, so there is no change. And I believe if you go back to one of my previous videos, I also tested my 386 without any cache. I think it got almost the same scores. So we have around 15 megabytes per second in the reading benchmark, and now we have 25 in the writing, and moving will go exactly over the reading benchmark again. But there's no indicator of a cache anywhere. Oh, and it's not even as fast as the reading performance now. Okay, so as it looks like, K2s Retro Workshop was right. There is no cache being accessed on the CPU. That's a little bit of a shame, because that CPU should have cache. And we will look at this in a moment, maybe under the microscope even. We'll look at the CPU and which pin of the CPU is responsible for, or partially responsible for, managing the cache. Let's see if we can quickly see the speeds. So maybe when I'll cut the video, I'll put the results of the 386 board here, and then you can draw your conclusions on this one. So let's try the cache check. But oddly here, I see there is a difference between 1 kilobyte and 2 kilobytes. So maybe there is something, but it didn't show in SpeedSys. Okay, so it looks like we have 1 kilobyte of cache on the CPU. There is a difference. Yes, this machine seems to have 1 cache. Huh. Interesting. Yeah, then I think I will just run a few benchmarks now and we will see what's the difference between Cyrix cache enabled and Cyrix cache disabled. Okay, now since we have seen all these benchmark results, let's go into the BIOS and disable the Cyrix cache, and then we'll see how the numbers change. Oh, wow. I didn't expect that. How? This is even slower than my 386SX on the other board. And here we can already see that the memory bandwidth dropped from, I think, 88 to 55. We get 6.14. Wow, that's a lot lower than I expected. So yeah, now we are back at 386 levels. We basically lost all our advantage of having our 486 instruction on the CPU. This one is close to a 386 now. That is eye-opening, and I think I don't have to do much more testing here. I don't even want, well, I will run Doom and I will present the scores after that benchmark. But yeah, this cache seems to be properly implemented. So I'm not sure what happened in K2 Retro Workshop's video. Let me maybe double check what he tried to test, and then maybe I'm just testing other things and it works fine. But I think this board is working very well. So I rewatched K2's Retro Workshop's video and he had issues running Doom in real mode. Now here I have EMM386 running, so this is going to switch our CPU into protected mode. Let's just get rid of everything here. I want to also get rid of the high memory area. I just try to reproduce whatever issues he had. Now the problem is he had a different CPU. He had a clock doubled CPU with 40 megahertz, I believe. So yeah, this is maybe why my CPU seems to be working and his may not have. So let's just quickly check in which mode we are in. We can check this using check CPU. And here we see that we are currently in real mode. So this is exactly what I think the issue was. Let's try Doom now. I will use the minimum details and let's see if it starts. Yes, so this one looks fine. I cannot reproduce what K2 Retro Workshop has shown in his video, but it might be because it's a different CPU. So his is a clock doubled CPU, mine is just a regular SLC. Okay, as promised, we will figure out which pins are responsible for enabling the cache. I found a documentation of exactly this TI486SLCE, and in the bus interface, we can see that, so here are functional signal groupings, and we can see that there seem to be two pins that are responsible for the internal cache interface. So we have KEN and flush. Now if I go to the next page, you will see, so flush is the cache flush, and the K enable is cache enable. Now if we go further down, you will see a more in-depth explanation what each pin is doing. And we will find flush with this information. And the first thing I found is it said it's optional. We don't need to read through and understand everything, but it looks like there's a way to also enable flush by setting some registers. So this is written here. You can read it if you want to, but important is that that pin doesn't have to be connected. There is another way of doing that internally. Now let's check the other pin that we have, which was KEN. And here we get a lot more text to read through. But the important part is that also this pin is optional. There's another way to trigger this signal internally again. So let's go back to our CPU. We have pin number 1 here. So here's pin number 1, this small dot, and you can see also here there is there's an arrow somehow that indicates on the PCB that this is pin number 1. And I will show now a pinout diagram. You will see that this is pin 1, 2, 3, 4, 5, and so on. And we can quickly verify this if I go ahead and use my multimeter. One side is on ground and the other side is here. So the second one I think is a ground pin. This is pin number 1. This one should be connected to ground. Yes, and then we have, I think, 2 non-connected pins to ground. Then we have again a pin connected to ground. Okay, and then we have another one. And then we have nothing, I think, until pin 11. And then there should be 4 pins. And you can see that already here they are connected also on the PCB. So all these 4 pins are connected to ground. So definitely this is pin 1 till pin 25. This is 26, 27, 28, 29, and 30. So these 2 pins, 29 and 30, they are our KEN signal and flush signal. And if I go a little bit closer, yeah, maybe this is good enough, you will see that none of these first pins have traces leaving under the chip. So they are indeed not connected. So what I think is happening is that the chipset that is on this board and the CPU maybe together, they are triggering the signals that are required to activate the cache internally. There are no external connections to the CPU, and it could make sense because we have seen on this board there are just a few components and everything else seems to be integrated in the chipset. So maybe this chipset is smart enough to send all the signals required without having to have all these traces connected. That's my only explanation, but of course, if you know better, let me know in the comments. I wouldn't know how else to explain that this board seems to be working perfectly fine with the cache enabled. Now, I don't know if I can just transplant this chip to the other board, because the other board has a 386SX from AMD. So not a version that is a 486 or has 486 instructions. The thing is, if I go here and I look at the pins, you see that pin number, so this was 26, and it's also written here on the silk screen. So you will see 26, 27, 28. So here's our KN signal, and here is our flush signal that was on our 486 SLC. But if I look at the pinout of the 386 SX, you will see 2 totally different signals. Yeah, so I'm not sure if I can just transplant this chip to this board and expect it to work. So yeah, now the big question is, do I want to attempt to swap this CPU with the 386 on the other board? Or should I just keep them as is? Now, I'm not going to lie, I like this yellow board and I don't like it. There are 2 things. First of all, it looks like it's bare minimum, but it could be that there's a lot of things integrated into this chipset and maybe that's making it so much better. And the other thing is that it's a very tiny, compact board that seems to be running very well now. I'm sorry for this, but I'm not going to swap the CPUs today. Let me know in the comments if you think I should just leave the CPUs as they are right now on those boards and just make peace with it, or do you want me to swap the CPUs? I hope you still enjoyed this video. If you did, give this video a like, write a comment, let me know what we should do in the future video with these 2 boards. And that is all for today's video. So thank you so much for your time. Thanks for watching. A big shout out to all my Patreons. If you want to support me, you can head over there and pick one of the memberships. And this is all for today. Take care and bye-bye.